Well, gosh, Brad and Donna aren't here. I don't know what's going on, but let's go ahead and get started. I don't want to waste you guys' time, but maybe they'll show up before it's over. Instructions for constructing a truth table. The point of the truth table is to prove whether an argument is deductively valid or just posing as a valid argument. Remember the two imposters? Nice variables on you two. Say, why don't you show us how they work, right? The truth table will separate the sheep from the goats. Here's how it works. Let's take this argument. If it rains, then we get wet. It rains, so we get wet. Step 1. Bracket and name with a letter all simple sentences in the passage. That is, bracket and name everything that is not a connective. I always identify compound sentences that use only negation at this point as well. So you can see here for it rains, we've bracketed it and we've named it with the letter R. For we get wet, we've named it W. And the if-then, that's one of the connectives. It rains is named R because we already named it R. So we get wet, well, we already named we get wet W. Step 2. Now pull the form or skeleton of the argument out. In other words, rewrite the argument symbolically using only connective symbols and letter names that you've assigned. Now for the if-then connective, you can either use the arrow, which you see right there or at the top, or if you want to go old school, like when I was taking logic class when I was your age, you can use the horseshoe. People used to always use the horseshoe. But logicians in modern times have kind of gotten away from the horseshoe because they believe it's bad luck to have a horseshoe on its side like that. Put the premises above the conclusion as below. So now how that reads in English is if R, then W, R, therefore W. The arrow or the horseshoe is the symbol for if-then. It shoots the if out in front of the first letter, and then it stands for the word then. So that reads, if R, then W. And down at the conclusion, you can see there are those 3 dots after the colon. The 3 dots, the 3 dots are the international symbol for therefore. No, Kenny, I said it's the therefore symbol, not the horseshoe. Therefore. Step 3. Now draw a truth table and put the symbolic form of the argument horizontally across the top, with premises first and conclusion last. You can see here I've got for P1, if R then W. P2 is R, conclusion W, and it's all spread out horizontally on top of where the truth table is going to go. I mean the rest of the truth table, of course. Step 4, Now put your cheaters, each letter used, in columns to the left of the argument on your truth table, and blacken the line separating the cheater from the premises. We blacken that line just so you won't confuse the letters, the cheaters, with the argument itself, because they're not part of the argument. The cheaters are just what we're going to use to figure out all possible truth values for R and W. Count the number of letters, figure out how many columns you'll use using the 2 to the n formula. Fill out the truth values for your cheaters. Well, 2 to the n, well, let's see, n is going to be the number of letters used total. There are 2 letters used total, R and W. 2 to the 2 squared is 4. So there are going to be 4 possibilities. For R, we're going to do half true, half false. For W, we're going to do a fourth true, a fourth false. So for R, reading vertically in the vertical column, it's true, true, false, false. For W, it's true, false, true, false. Now that gives us every possibility concerning R and W. R and W can both be true, or R can be true and W can be false, or R can be false and W can be true, or they both can be false. So imagine the sentence, if it rains, then we get wet. The first possibility is that it rains and we get wet. The second possibility is that it's true it rains, but false we get wet. The third possibility is it's false it rains, but true we get wet some other way. And the last possibility is that it's false it rains and it's false we get wet. Step 5, use your cheaters to calculate the possible truth values of the premises and the conclusions given the connectives being used. Remember that under the sign of the if-then, the sign of the arrow, the sign of the horseshoe, if the antecedent is true and the consequent is false, then the if-then statement is false, but it's true in all other cases. So in the case where R is true, W is true, if R, then W is true. In the case where R is true, W is false. If R, then W is false. That's the one case where it's false. If the antecedent's true and the consequent's false, then the whole thing is false, true in all other cases. In the third row, R is false, W is true, means if R, then W is true. And if you don't understand that, go back and watch the one about Hillary Clinton being a professional basketball player. And in the fourth and final row, R is false, W is false. That means if R, then W is true. Why? Because that's just how we assign truth values using our cheaters under the sign of the Then determine if it is valid or invalid by discovering if there is a horizontal case, a horizontal row of true premises and a false conclusion, TTF, right, valid, or invalid. Okay, the first thing to do is to eliminate the cheaters.
You are no longer useful to us.
Whoa, whoa. And TTF is the only one that matters. If both premises are true and the conclusion is false, the whole argument is invalid. If it's possible to get true, true, false, it's an imposter, not an actual deductively valid argument, so it's invalid. Okay, in the first horizontal row in the argument, we have true, true, true. That proves nothing. In the second horizontal row, you have false, true, false. That proves nothing. True, false, true proves nothing. The one we're looking for is true, true, false. That would prove it was invalid. The other combinations don't prove anything. They mean nothing. And the last horizontal row, you have true, false, false. That's not the same as true, true, false. That means nothing. This argument is valid. It kind of makes sense because if you look at it, you'll see it's the skeleton of modus ponens, one of the deductively valid forms. So we've proven that modus ponens is valid. You know what this picture shows? It shows that it's impossible with this skeleton argument to get true premises and a false conclusion. And that's the very definition of deductive validity. To summarize what we've seen here in this video, we have noticed that it appears that one of those arrows we were using to represent if-then pierced the head of Donna and Brad's head too and killed both of them. I guess this was one time when even on its side, the horseshoe was luckier than the arrow. Kenny, are you going to put in that sound effect? See you next time.